So section 4.4, we're talking about adding and subtracting rational expressions now. The last couple days we've been talking about multiplying and dividing as well as simplifying rational expressions. We're going to see a little bit of all of it today. I'm going to take us back to a little bit of elementary math here real quick. When we look at this example 1, when we're adding and subtracting fractions, what do we have to have?
Common denominator.
You have to have a common denominator. Is that true here?
Yeah.
Yep, so that common denominator, if we have it, we keep it the same. What do we do with the numerator? Add them together. 1 plus 1 is 2. What does that simplify to? 1/2. However, on example 2, do we have common denominators? No. I have 3 and 4 as my denominators. We have to turn it into a common denominator. How do I do that?
You find like the, what's it called?
It's called a least common multiple.
Yeah.
So we want to find a number that goes into that both 3 and 4 go into. What number is that? 12. So what we want to do with that, I'm going to come over here and work to the side. If I'm looking at 1/3 and I want to turn it into something over 12, how do I do that?
Multiply by.
Right, I want to find a number I can multiply by. Does everyone agree 3 times 4 gives me 12? Okay, what I do on the bottom, I also want to do on the top. So what's 1 times 4? 4. So for our 1/3, we get 4 over 12. Now we do the same process for 1/4. We pick 12. What times 4 gives me 12? 3. So 3 times 1 is 3. So then we get 3 over 12 for our 1/4. So what we did here is we just replaced our 3/4 and 1/4 for common denominator fractions. So now, can we add these two together? Can we add these two together? Yes, we keep our denominator, and then what do we do? Add the numerator. 4 plus 3 is 7. Okay. So in order to add and subtract fractions or rational expressions, we have to have a common denominator in order to do that. Okay? Moving on to our rational expressions, this is your example 1A in your notes. So go ahead and flip your notes to example 1A. So we have rational expressions. What operations happening? Addition. What do we have to check in order to add and subtract?
The denominator.
Denominator. What does the denominator have to be? Has to be the exact same. Is it the same? Yep, they're both 2x plus 3. So we are going to have our denominator as 2x plus 3. What do you think we do with the numerator? It is going to be combining like terms. So we have 10x plus negative 4x, 6x, and then we have negative 5 plus 8 plus 3. Now, once we get to this step, we always want to see if we can simplify, just like we did with the 2/4 in our example. Okay, so just like we did yesterday, we always looked at both of them separately. Look at the numerator. Can I take anything out of those two terms? Take out a 3. What's left if I take out a 3? 6 divided by 3 is 2x plus 3 divided by 3, 1. And then can I do anything with my denominator? No. So denominator is going to stay the same. Does anything cross out or cancel out? Good question. Can I take these two out?
No.
Why not? Right. This one's with the plus 1. This one's with the plus 3.
Why can't you just cancel the 3 out and then have 6x over 2x?
Oh, right here? You cannot do that because they are split apart by addition. If it was like multiplication, then you could. Yep, but since they're split up by that addition, we cannot. So this is our final answer to 1A. Okay. Go ahead and try 1B. First thing you need to look for is what? Right. Always want to check what operation's happening first. What operation's happening? Addition. Then you check, since it's addition, check if your denominators are the same. Are they the same? Yes, so we keep that denominator, x plus 5. What do we do on the top? Combine what? Combining like terms. So we have x plus 3x 4x, and then we have negative 5 plus negative 21, negative 26. Am I done here? What do I always want to check? If I can simplify, what can I do with the top? I have two terms. We always want to see if we can take something out. I cannot take a 4 out, but I can take something out. I can take a 2 out. Yep. What's 4 divided by 2? 2x. Negative 26 divided by 2? 13. Can I do anything with the bottom? Nope. Most of the time, you're not going to do anything with that bottom term. Okay?
If it's the same.
Yes. Now I'm done. Can't cross anything out, so I'm done. Now we're going to look at examples where our denominator is not the same. Okay, so I'm on example 3a right now. On example 3a, what operation's happening? Addition, so we have to check for what? Seeing if we have a common denominator. Do we have that right now? No. So we want to turn them into common denominators. Now, looking at them right now, is there an easy way where we can turn x squared minus 4 into x squared minus 5x plus 6? Like, is that kind of confusing looking at that? What is a simpler form we can use for those two denominators?
Factor the bottom.
We're going to factor the bottom, okay? I'm going to keep the top the same, so I'm just going to rewrite x plus 6. What does x squared minus 4 simplify to? Remember, it's the perfect squares.
The
X plus 2 and
minus
x minus 2. Yep. So now, same thing on the other fraction. I'm going to keep the numerator, and I'm going to factor the bottom. So factors of 6 are what? 1 and 6. 2 and 3. What is going to get us to negative 5? Either or, but we have to have one of them. Since this is a positive 6, are we going to change one of them or both of them? We have changed both. So if I change both of them, which one's going to get us to a negative 5? The second one. Yep, negative 2 and negative 3. How do I write that as factors? X minus 2 times x minus 3. Good. Right, they are not the same, but is this easier to look at than what we were looking at before?
Yeah.
Yes. So I want to ask you this. What is the same between the two? Do you agree they have x minus 2 in common? Okay. What is this denominator missing compared to this one?
an x. I did it 1.
In addition.
So think we have x plus 2 and an x minus 3 here. What is this one missing that this one has? The x minus 3. So I'm going to multiply both the top and the bottom by what it's missing. So this fraction is missing x minus 3. So I'm going to multiply it by x minus 3.
My math top.
Okay. What is this fraction missing that this one has?
Minus 2. Wait, yeah, x minus 2.
X plus 2. It's missing x plus 2, so I'm going to multiply by what it's missing on the top and the bottom. Now, do you agree, looking at this, they are the exact same? Yep, so our next step, we're going to keep our denominator, x minus 3, x plus 2, x minus 2. I'm going to ask you this. Does it matter the order I write these in?
No.
It does not matter. Okay. What do you think we do with the top?
Combine like terms.
Can we combine like terms right now?
No,
We can't.
you have to multiply it.
We have to multiply them out. Yep. So x times x is what?
X squared.
X squared. X times negative 3.
Negative 3.
Negative 3x. 6 times x.
6x.
6x. And then 6 times negative 3.
Negative 18.
Negative 18. What do you think we need to do with this?
Do the same.
We need to distribute that 2 in, right? 2 times x is
2x.
2x. 2 times 2 is
4.
4.
Okay.
Okay. Now, can we combine like terms?
Yeah.
Yes, so I'm going to keep my numerator always. or sorry, my denominator always. So we have x minus 3, x plus 2, x minus 2. Combining like terms on the top, does x squared have a like term? Nope, so I'm going to keep x squared. Now I'm going to combine my x's. What's negative 3x plus 6x?
3x,
3x plus 2x?
5x,
5x. So plus 5x. And then negative 18 plus 4.
Negative 14.
Negative 14.
and then let me add factor.
Right, because we want to simplify, so we need to factor the top. So what are factors of 14 that can get you to 5?
14,
1 and 14 and 2 and 7. Which of those are going to get us to 5?
2 and 7,
How?
negative 2.
Negative 2. Yep. So how do I write that as factors?
X minus 2 times x plus 3 plus 7.
X minus 2 and x plus 7. Does my denominator change? Nope, stays the same. Denominator, once you have a common denominator, it's going to stay the same the whole time.
Wait, okay, now you can force
Right, now we're at our canceling step. What do they have in common?
x minus 2.
X minus 2.
That's it.
That's it. So what is my answer?
X plus 7.
Whatever's left, right? X plus 7 over?
X minus 3.
Times x plus 2.
Yep. And then once you're all simplified, you're all done.
Yay!
We did it.
So long.
We did it.
Barely.
In those steps, what we were doing, do you agree everything except this step right here we've done before?
Yes.
Every step in that process we've done before, just this step getting us started is new. Okay? But we've done this before, we've done this, and we've done this. Okay? So it's kind of building off of each other. Example 4B. Example 4B. What do you notice about this one? It's subtraction, okay? However, is the process still going to be the same? It is still going to be the same. Since it's subtraction, what do we have to check for?
Negatives.
Common denominators, and we got to be careful with negatives as we work. Common denominators, do I have a common denominator? No. What do I do? So if I don't have a common denominator right away, I got to do what?
Make it common.
Make them common. I want to simplify this, right? So I'm going to keep my numerator the same. What does x squared minus 25 factor to?
X plus 5 minus 5.
X plus 5, x minus 5. And then can I do anything with this denominator here?
You add what's missing.
Right. For right now it stays the same, but now we want to see if we can make them the same. What is this one missing that this one has? It's missing that x minus 5. So what do I do with it?
You gotta multiply it by.
Yep, we're going to multiply this fraction by what it's missing on the top and the bottom. Is this fraction missing anything?
No.
No, so do I need to multiply it by anything? No, that one can just stay the same. So when I rewrite this, I have my 3x minus 5. Let me pause for a second. We have our denominator, right?
Yeah.
Okay, so I'm going to write my denominator. X plus 5 times x minus 5. Did anything happen to this?
No.
Nope, so I'm going to keep that. 3x minus 5. What do I do here?
Put it like the 3x minus 5.
Right, I'm going to multiply this 2 in, but one thing we have to be careful with is the subtraction sign. What I want you to do is switch it. Okay, so we have negative 2 times x is
Times 6.
negative 2x. Then we have negative 2 times negative 10. Sorry, I just told you the answer. Negative 2 times negative 5 is positive 10. Okay. What is my next step? What's my next process here? Combining like terms on the top. 3x minus 2x, 1x, negative 5 plus 10. Plus 5. What do I do with the denominator? Keeps it the same, yep. So we have x plus 5, x minus 5. What's the last thing we need to do?
Cancel.
Canceling things out. What cancels?
X plus 5.
X plus 5. What's left?
X minus 5.
Gotta be careful. Is x minus 5 on the top or the bottom?
Bottom.
So it got to stay on the bottom. What do we put on the top?
1.
A 1. Yep. So remember, wherever it ends up, you have to keep it there when you're writing your final answer. Okay. I have one more example that I want us to look at. Okay? I want you to try this one. To make it a little nicer, I want you to change this to an addition sign. All right. What operation's happening?
Addition.
Addition. So what do we need to add or subtract?
Common denominator.
Common denominator. Do we have a common denominator here?
No.
No, we need to, add what's missing.
Yeah.
Right, we need to multiply by what's missing. What do they both have? They both have that x plus 4. What's this one missing that this one has?
X plus 3.
So what do I do with that?
Add it on the top and bottom.
Multiply by what's missing. X plus 3, x plus 3. What is this one missing that this one has?
X plus 5.
X plus 5. So, what is my common denominator?
X plus 3.
X plus 5. X plus 4.
Good. What do I do with the numerator?
You distribute.
Yep. X times x is
X squared.
x squared. X times 3,
3.
3x. What do I do with this?
Distribute.
4 times x, 4x. 4 times 5,
20.
20. Am I done? No, what do I do?
Wait, slow down.
How I got this?
Yeah.
Because from that first step, we made that common denominator on both of these. So I get that common denominator from whatever I have there.
Oh.
Yep, because these two right now are the same. So that's why I can put it as my
Can
denominator.
we keep them separate until we combine them? And put them together?
Yes, it's the same thing. So do you agree that my common denominator is going to stay the same the whole time?
Yes.
Okay, yep, so I don't ever do anything with my denominator. What do I do with the numerator? Combine like terms. Does x squared have a like term?
No.
Nope. 3x plus 4x,
7x.
7x. What about plus 20?
Plus 20.
Yep. What do I do at this point?
Factor it.
See if you can factor, right? Because we always want to simplify. What are factors of 20?
1 and 20.
1 and 20,
2 and 10.
2 and 10,
4 and 5.
4 and 5. Which of those is going to get us to 7?
No.
None of them, right? So what do I do?
Circle
Yeah.
it, you're done.
Yep, that's your answer. Remember, if you can't simplify, so right now this is in simplest form because we can't simplify any farther. Okay? A couple Remember, when we are adding and subtracting, what do we have to have? Common denominator. Do we have that?
Yeah.
So if I add these together, what's my denominator?
X plus 1.
X plus 1. What do I do with the numerator?
Add
So 3 plus 11 is 14. Can I simplify any farther?
No.
Done. That's it.